All right, so this is going to be our last video on this topic, and we're going to take a look here at relative motion in two dimensions instead of one. So now we have an airplane. Oh, one note. If you're looking at this in your notes, it says 200 meters per second east and 10 meters per second north. I want you just to make a change and change that 10 meters per second north to 45 meters per second north in your notes so we can go through this example. In this example, we have an airplane that flies 200 meters per second to the east with respect to the air. So it's flying through the air at 200 meters per second. The air is moving 45 meters per second north with respect to the ground. So it's flying through the air. The air is moving relative to the ground. And what I want to know is how fast is the plane moving with respect to the ground. We're still going to do vector addition here. So we're still going to say that the velocity of the plane with respect to the ground is equal to the velocity of the plane with respect to the air plus the velocity of the air with respect to the ground. The only difference between this and a one-dimensional motion where everything is in a line is that when we add vectors that are at right angles to each other, we have to use right triangles. So instead of just adding 200 to 45, we have to find the hypotenuse of this right triangle. To do the hypotenuse of the right triangle, we're going to use Pythagorean's theorem, which would say that's a squared plus b squared equals c squared. So our vector addition here is going to say the velocity of the plane with respect to the ground as we add them like vectors. It's going to be the square root of the velocity of the plane with respect to the air squared plus the velocity of the air with respect to the ground squared. So again, we're just adding these like vectors, same sort of process, just that when we add vectors at right angles, we take this process. Looking at this, we could plug in our velocity of the airplane with respect to the ground and our velocity of the air the velocity of the plane with respect to the air and the velocity of the air with respect to the ground, square them, and we end up with an answer of 205 meters per second. So whenever you are trying to find a relative motion example, you're trying to find the velocity of something relative to another, and you need that linking velocity, what you need to do is just make sure that if it's in one direction, it's just adding and subtracting. If you take a look and one is perpendicular to the other, what you're going to see is that they are not going to set up like that, and you're going to have to treat them like a right triangle and find the hypotenuse. This next example, you're going to find in your Nearpod, and I'd like you to try this example. And it's a river crossing. This is a very classical example. You have a boat that's coming across the river at 0.75 meters per second. The river's flowing perpendicular to the shore at 1.2 meters per second. It's the same process that you did for the plane. You have the boat going one way, you have what it's going through going the other, and you're going to try to find the velocity of the boat relative to the shore. Once you finish up this example in the Nearpod, when you go back to your Microsoft Forms, you got a couple of questions that are just going to see how well you do relative motion examples. Complete that, and then you'll be all set with the notes. And I will talk to you when you get back next week.